All right, in this video, I'm going to talk to you a bit about the normal distribution. Those of you who were in Mr. Kemp's class last year, you will know a little bit about this already. Okay, and those of you who were in my class or Mr. Crispin's class, this might not be very familiar at all. So this will be important for you to have a good listen to. So when we're talking about a normal distribution, we're talking about how data is spread out, how different people or different animals or objects that we have measured are spread out on a graph. And then we can use the way that they're spread out to help us calculate some probabilities of picking another person and seeing where or how likely it is that they fit in a certain place on the graph. So normal distribution, like we said, it's about how data is spread out. And we can see data spread out in lots of different ways. Sometimes it's spread out more to the left. We'd call that skewed to the left. Or sometimes it might be more to the right, skewed to the right. Or sometimes it's all jumbled up like this. But a normal distribution graph looks like this one, where it is symmetrical and has a big bump in the middle. And then it has these tails on either side where it trails off, and we get less and less people on the ends, the extreme sides of the distribution, and most people are bunched up together in the middle. Okay, so we've got the blue line, which is the normal distribution curve, which is a mathematical formula that gives us a perfect curve. And then the yellow stuff is what we would actually measure in real life for people or animals or what have you, and put it on a graph, and you'll notice that often it will match this type of curve reasonably well. Not perfectly, but pretty close. Okay, like it says here, the blue curve is a normal distribution. The yellow histogram shows some data that follows it closely, but not perfectly, which is pretty normal. And we call it a bell curve because of the shape looking like a bell. Now, lots of different things can follow a normal distribution, and the height of people or the weight of things or the length of something, different animals or what have you, can often be good examples of that. Now, for a normal distribution, there's a couple of key numbers that we need to know to describe it. And the most important one, or the first one that we usually think about, is the middle value, right down the middle. And we call that the mean, okay, or the average number, but the word we most commonly use would be the mean for that. Okay, so you'll see that here. This is the mean, right down the middle. And because it is a symmetrical distribution, we'd have half of the people or the objects or things, animals, on one side and the other half on the other side of the mean, which goes perfectly down the middle. Now, the other number that we need to know about besides the mean is the standard deviation. And the standard deviation is a measurement that tells us how spread out our numbers or our people, our animals are on the graph. How widely spread does the graph go? Okay. There are other ways of measuring how spread out things are, and one you might be familiar with from last year is the interquartile range, or even just the ordinary range, which tells you highest number to lowest number. But the standard deviation is another measurement, and it gives you sort of an average amount of how spread out things are. We're not going to go into detail of how you calculate it. You just need to know what it means, that it's how spread out things are. And so what we often think about is how many standard deviations we have stepped away from the mean in terms of different measurements that we're thinking about. Okay, how far away from the middle is a particular value, particular measurement? How many standard deviations away from the middle is it? And it turns out with this perfect normal distribution curve that if you step away from the mean by one standard deviation on either side, then the amount of people or things that fit in that area, in that shaded area, is always going to be 68%. No matter what thing it is you're measuring, no matter what the values are, if you start at the mean and you step one standard deviation away from the mean and one less, you get 68% of people in there. So for example, let's say we measured a bunch of teachers and we discovered the average height of those teachers was 170 centimeters tall. Okay, so that would be right down the middle, the mean 170. And let's say that the standard deviation was 10 centimeters. And so that would mean then if we went 10 more than 170, so we get to 180 out here, and 10 less, so we get to 160 down here, we would find that 68% of the teachers we measured would be in that area on the graph. So 68% between 150 and 160 and 180, assuming that the mean was 170 right down the middle and the standard deviation was 10, plus or minus 10 on either side. Okay, now it turns out if you go 2 standard deviations, you take another step. So we go 10 centimeters plus 10 more. So we've gone 20 centimeters away from the average. Then we would find, in that case, 95% of our teachers would fit in that area on the graph. So if we've got 170 in the middle, we go 20 down, we're down to 150. That's a pretty short teacher. There wouldn't be many teachers of that height. And if we go more than 170, we go 20 more, we get to 190. That's pretty tall. There wouldn't be too many teachers that were that tall or taller. Turns out 95% would be in that area. Okay, and then if you go 3 standard deviations, you've nearly got every single possible value. You'll see it goes to 99.7% if you go that far. So the further and further away from the mean we get, the more and more people we find in our shaded area, and the less and less people that are left over outside of that area. So if you think about what's left, you've only got 0.3% left to get to 100. And that has to then be split up between this side and that side. So there's a very tiny, tiny proportion or percentage of people that would be in these areas out here going past 3 standard deviations. All right, so that's a little bit about what the normal distribution tells us. It tells us what an average amount is for a person or a thing, whatever it is we're measuring. It tells us that most of those things, many of those things are pretty close to that average. Right, coming back here, 68%, so that's like 2/3 of people are within 1 standard deviation either side. 95% are within 2, and that's meaning that we're getting less and less and less people at the extremes. Most people are actually in the middle, and it's this symmetrical shape. Okay, so evenly spread, symmetrically spread either side of the mean, which is in the middle. All right, so that's a normal distribution graph. Now, the next thing you guys need to know is how to use it to make calculations. So I'm going to bring up my calculator. Hopefully you can see that. What I'll actually do is I will do a screen share of these two. Here we go. So they're next to each other, and hopefully, this isn't really working. I will just go. Yeah, that one. Will this work now? Let's try. Okay. So now I'm screen sharing. I want to maximize that one. Can I go like this? Here we go. Hopefully you can see that. Okay, and so we've got the calculator over here and the normal distribution problems over there. I'll just go back to the main menu so you can see what's happening. All right, so what you need to be able to do is use a graphics calculator to make probability calculations using normal distribution stuff. Okay, so on your graphics calculator, you turn it on, make sure you're on the main menu area so you know what you're looking at. You can push the menu button for that. And we're going to choose the stats mode. Okay, so you can move around like this to highlight stats and then click the blue execute button. You won't see that on my screen, but it's down there. Or you can just push the number 2 because it's the second function. So number 2 or highlight stats. So that's the one we want. On your worksheet that you'll have with you, you'll see there's the same instructions, the main menu, stats. Then for number 2, you're going to push F5 for distributions. All right, dist is just above F5, so we'll push that. Then you want F1 for normal distribution, F1. and then F2 for NCD. All right, there's an NPD, but we want the NCD, F2 for that. Okay, so we'll follow those 4 steps. Now, this is an older version of the calculator. Some of the newer ones have a few more options. If you see up the top this thing saying data list, you will need to push F2 to change the list to variable. Okay, so you should see this on your screen, data, variable, and all this stuff. For my one, I just see, I don't have that thing, I've just got the lower, upper, etc. Okay, I will just clear all these for the moment, and we'll put that in there and that in there, so it all matches what you see there. Okay, so we've got 0, 0, 1, 0. That's what you should normally see on your calculator. Now this symbol, here it is, that is pronounced sigma. It's a Greek letter, and it's the symbol we use for standard deviation. So when you read your question and find out what the standard deviation is, we're going to put that in there. And mu, that's what this one is, mu, just like the Pokemon. That's another Greek letter, and that's the symbol for the mean. All right, and now that you're there, your calculator's ready to go, and we'll have a go at some example questions. So here we go. I'll show you the first one, and you can try the others on your own. So Tamatea has a kumara field, and at harvest time he weighs them. He finds that they have a mean weight of 185. So I'm going to go do that right now. The mean weight is 185. I'll just type 185 and push the blue execute button. And then a standard deviation of 16. So I'm going to go up again to the standard deviation, type in 16. Just push the execute once at a time. Don't push it twice. Otherwise, it's going to try and work out a probability, and it'll tell you something weird that you don't want to know. By the way, if you did accidentally and you ended up here, just push the exit button once, this one below the menu, exit, and that'll take you back here. All right, now the question says for part A, what proportion of Tamatea's kumara weigh between 160 grams and 190 grams? So our lower value for the weight of our kumara that we want is 160. The upper value is 190. So we'll go and put those in. Lower 160 and then upper 190. Okay, so they're telling me what's the minimum weight of kumara you're happy with, what's the maximum weight you're happy with. Put them in the calculator. And now we will push the execute button twice. We'll push it again to get our answer. And here it is. There's a whole lot of stuff, but the one we're going to pay attention to is P for probability, or P for proportion. Okay, they're basically the same idea. And it's 0.563, and we'll round that to 6 because of the next number being an 8, 0.5636. So there we are there. That would be the answer for that first one. So part B, for that we'd push that exit button, not execute, exit. And then we can go back and change our lower and upper numbers to match part B and figure out what that answer is. Now part C is a bit different. It says for all the kumara that weigh less than 150 grams, talks about taking them to the fish and chip shop, what proportion will be sent to the fish and chip shop. So these are the small kumara, and they weigh less than 150. So that means that the most that a kumara would weigh to be sent to the fish and chip shop, the most that it could weigh would be 150. It wouldn't weigh any more than that. That'd be the most. And then everything less than 150 as well is also sent off to the fish and chip shop. So the upper amount, the most that it would weigh, is 150. It couldn't weigh any more, okay, because it's less than 150 is what gets sent off. So the lower value then, the upper is 150, the lower value, we've got to think about that carefully. These kumara could weigh, anything that's less than 150. So I guess the lowest possible would be a weight of 0. But remember, we're using this mathematical curve in the calculator, this mathematical formula of the normal distribution curve. And that curve can actually go on forever. It can go down past 0, okay? In real life, kumara don't go past 0, but on our mathematical curve, it can. And so for this lower value, where it can just be anything lower than 150, we're going to put in a negative number that's really, really, really small, way, way, way lower than 0. Okay, so we've gone way past 0. May as well put infinity. You can't actually type infinity, so we'll put negative and then a whole bunch of 9s for a giant number. Okay, and so we'll put that in. That's our lower value. And then we'll push go, and the calculator will tell us an answer. Okay, and we've got 0.0144. We'll round that 3 up to a 4. 0.0144. Remember the 4 decimal places that you want in a probability answer at level 3. All right, part D, read that carefully. If they weigh more than 220 grams, they're sold to McCain's, and then the rest of them will be bagged up and sold to the supermarket. Okay, so some are sent to the fish and chip shop if they're less than 150. The big ones that are more than 220, they're sent to McCain's for kumara wedges, and then the rest get sold to the supermarket. Which proportion go to the supermarket? So the supermarket ones are the ones in between the 150 and the 220. So those are telling you your upper and lower numbers that you're going to type in there. All right, I'll leave you to figure that one out. Now we'll just have a quick look at some of the other ones and see if there's anything a bit weird going on there. This one, more than 105 days. Okay, we'll read this real quickly. We've got a farmer, and it's telling us about cows and how long they're pregnant for. There's the average, and there's a standard deviation. So you would need to go and change your mean and standard deviation here to match those numbers. And then if we want it between 90 and 100, there's your upper and lower numbers. Here, how many would be more than 105? So more than 105. So 105 is the lowest we're interested in, the least amount of days. And everything more than that is what we would be interested in finding out about. So our lower number would be 105. But then our upper number, the most it could be, well, there is no most. It's just saying more than 105. If there's no most, we'll just put a big giant number there for that. So this one's going to be a positive gigantic number, way, 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 way more than 0, rather than way less than 0 like we did for that other one. Okay, just put in a big giant number. Doesn't really matter what the number is so long as it's huge, and the calculator will be able to give you the answer you're looking for. Okay, then obviously you would need to switch your mean and standard deviation like we talked about. Okay, those of you who are paying attention, you'll see that the question actually asks about how many cows. He's got 650 in his herd. How many would be pregnant for more? So you'll need your proportion, your probability you get from the calculator, and you'll need to work that out as a percentage of how many of those cows actually are the ones that end up pregnant for more than 105 days. So I'll let you figure that one out and help each other out if you're getting stuck. Okay, this one, I'll let you think about how you might do that. There's some interesting things to think about there. Okay, it's not too difficult, but there's 2 parts to the question. Less than 85, so you'll have to work out what less than 85 is for a probability. And then more than 110, so you'll have to work out what's the probability of more than 110. And then you'll need to put the 2 of those together for the total probability of all of those that fit in both categories, or either category, sorry. Okay, so I'll let you think about that one, and then the rest you should be pretty good with. Okay, and that is the normal distribution and how to use a calculator to get those answers. Cool. Take care, guys, and I will see you as soon as I can.